Okay, so series, geometric series, they can converge. A convergent geometric series means the numbers eventually come down to just one number. Like for example, if you've got 1 plus 1/2 plus 1/4 plus 1/8, etc., etc. You know, you keep adding more and more numbers, but the numbers you're adding keep getting closer and closer to 0. Like this is getting relatively small. When you get to 1 to the 2 to the 500th power, then your calculator's not even going to be able to compute how small it is. It's just so close to 0. So this set of numbers we say is convergent. The series converges because their sum gets closer and closer to sum total. Now we haven't said what it is, okay? But if the sequence, the series we have over here to the left does not converge because look, the numbers that we're adding, they don't get closer and closer to 0 like my example. They're getting bigger each time. So we say the sum is not defined, okay? Let's see what else we got for this topic. Asked to evaluate the following geometric series from 1 to 8. So that means you could find out how much, what k equals 1 is, plus what k equals 2 is, plus what k equals 3 is. You could do it the long way, or you could use the formula I have on the board here for the sum of a geometric series. Okay, all you have to do is identify the first term, and the first term here would be if you plug in k equals 1. Oh no, sorry, the first term is like if you have a sub n equals a sub 1 times r to the n minus 1 power. Yeah, so actually for this one, the first term of 10 times -2 over 3k, you know, this would be if k equals 1, then the first term is -20 over 3. Just double check that. Yeah, because if you plug in 1 in for k, the first term is -20 over 3. So to find out that sum, s sub n, we take that first term of -20 over 3, and then subtract it by 1, and then do 1 subtracted by the common ratio, which is always this number that's being raised to the power, right? We're multiplying by -2/3 each time. So -2/3 to the 8th power, and then divide it by 1 minus that common ratio. So a bit of complicated fraction work we've got to do here, but at least we've got a one-stop shop for finding out that sum instead of having to add each term. Okay, so let me see what I can do here. -2/3, that one's kind of brutal. 2 to the 8th, that's 256. Got 1 minus 256, and it's positive now, right, because you're raising it to an even power. And then 3 to the 8th, 6561. And that's all being divided by 1 plus 2/3. So we got 5/3 on bottom. Alright, sorry, this is getting really messy, but I can copy and paste this so we can look at it easier way. Okay, that's where we're at for the summation. We plugged it in the formula, now we just need to simplify. Nearest hundredth, shoot, so we could have just used decimals this entire time. I was trying to keep the fractions, but let's just jump to, is 2 to the 8th really 256? Yeah, let's jump to a decimal approach, okay? That'll make our lives easier. So 256 divided by 6561 makes this number, and we need to subtract that from 1 inside that parentheses. So right now we've got -20 over 3 times 0.960982 if we round off. And then whatever that is, we divide by 5/3. Take this number, multiply by 20, divide by 3, and it was a negative. So the numerator is -6.4065. And so here's our denominator, 1.6 repeating. So take that numerator and divide by 1.6 repeating. So we got approximately negative 3.8439. And nearest hundredth, negative 3.84. Okay, so I was going to use the fractions all the way out, but luckily we get to use decimals. Okay, it'll be kind of tough work with common denominators and simplifying. I guess it wouldn't be too bad. But. Okay, maybe one last one here. Infinite series here. That means we keep adding and never stop. Let's see if there's a common ratio. Okay. If there's a common ratio, it's geometric, and then we can try to make some conclusions. But the common ratio, our estimate would be we take the second term and divide by the first term. That makes negative 2 over 3. And if it does have a ratio that's in common, you should be able to take the third term, 16 over 3, and divide it by the second term. If you do that, you get 16 over 3 divided by negative 8, which is 16 over 3 times negative 1 over 8, which gives us negative 2/3. So yes, we do have a common ratio. This sequence, a sub n, is the first term, 12 times negative 2/3 to the n minus 1 power. So we have a common ratio. So a quick way to rationalize this is that if this r, this common ratio, is less than, and actually we should say the absolute value of r, if that's less than 1, then it converges. If r equals 1, then we can't tell. Okay, we have to use a different technique. And if that r is greater than 1, then it diverges. So our common ratio r is less than 1. So we don't know what the sum is. We can do that in a later class, but at least we know it converges.